Okay, so there were a few of the example problems that we didn't work in section 7.1. In the first ones, we did try these A. I did them in the example A, so you actually have those in your notes if you took good notes that day. We did not do the try these B, which is on page 84. The directions say find the value of these expressions. So that just means standard form when I'm trying to find these values in regular numbers. So here, this is actually one that we did on Plickers. We talked about 15 is not in scientific notation, but I can put a decimal place after it and then add on 3 zeros. So if my decimal place was here and I added 3 zeros, I now have 15,000. Likewise, if I start with 2 and I add 6 zeros, I now have 2 million. And last, I have 43.2, and I'm going to add on a couple zeros. Now, the reason why I only added on 2 was because my decimal point was here. I added on 3 place values, 1, 2, 3, which gives me the 43,200. Now, D says, describe any patterns you noticed in evaluating these expressions. Well, the pattern is that I see is that the decimal is moving to the right the same number of times as that exponent. So decimal moves to the right the number of times as the exponent. So that's how I would phrase it. You can put that in your own words, okay? But that's what I have for the try these B. Now, we also did not do the try these C, which is on page 85. The directions for A say, what is the relationship between the exponent of the power of 10 and the number of places the decimal moves? Well, we kind of already addressed that in the try these B section, but basically the value of the exponent tells us how many places to move the decimal point to the right. So I guess I should write the exponent tells me, let's see, what do I want to say? Number of places to move the decimal to the right. Didn't leave myself very much room for that, but that's essentially what I'm saying. Okay, and then B says, rewrite the mass of the sun, which is 2.0 times 10 to the 20th kilograms, in standard form. So that's going to give me 20 decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then every third I need a comma. Okay, that's how much the sun weighs in kilograms. Shoo, I don't even know what that number is. I'll have to look it up on that chart. Okay, and then the rest of these are just rewrite in standard form. So I'm going to need 6 zeros. And the reason for that is that my decimal point starts here. 1, 2, 3, 4, 5, 6, 7 places, but only 6 zeros, right? Because I started off with 1 place right here. Now this one doesn't have any places after it, so I can add 7 zeros. I'm sorry, 12 zeros. I said 7 from the previous one, but 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's my new number. Okay, this one does have a decimal place after, so I'm going to move it 5 places, but that means I'm only adding 4 zeros. Okay, so if my decimal point was here, I'm just going to double check. 1, 2, 3, 4, 5, and I'm good. Okay, now I've got 24 zeros. Whew, that's a lot of zeros. Let's make sure I did it right. So the decimal points after the 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so I did the try these C. Try these D, which is also on page 85 at the bottom, says convert each number from standard form to scientific notation. Work backwards from your answer to check your work. Okay, so I need to write this in scientific notation. So my factor needs the first number that's being multiplied to 10 to a power. That first factor needs to be between 1 and 10. So I'm going to place my decimal point right after the 6. So that'll give me 6. And it looks like if I move it 1, 2, 3 places, that will give me 6 times 10 to the third power. Okay, here, in order to make my first factor between 1 and 10, I'm going to have 4.36. I'm going to drop off all the zeros, though, because that's the whole point of scientific notation, is shortening it up. 1, 2, 3, 4, 5, 6, 7, 8 places I had to move my decimal. Now here, I'm tempted to write a 16, but that's not less than 10, so I'm going to write 1.6 times 10. So if my decimal point is there, 1, 2, 3, 4, and I have my scientific notation versions. Now, it says to also work them backwards. I'm not going to take the time to do that, but basically what it means is check your answer. See if you cover these up and you work this problem as put in standard form like we did up here and try these C and see if you get the same thing. You should. Okay, that's how you check answers. Now I'm going to go ahead and go to try these E, which is on page 87. And it's above the check your understanding questions. So what these say is, it says write an estimate of each number using scientific notation. So there's two steps to this one. I'm going to write in scientific notation, but I'm also need to estimate to the closest value. So if I'm going to round to this place value, which is the 100,000th place, the number next door is bigger than 5, so I need to round that up to a 3. And then I need to see if that's a 3, right here would be my decimal point. So I need to count how many places does it move. 1, 2, 3, 4, 5. Okay, so that would be 3 times 10 to the 5th power is pretty close to 284,116. Same thing here. I have 5,218,996. Pretty close to just 5 million. So 5 is going to be my first factor that's between 1 and 10 times 10 to the 1, 2, 3, 4, 5, 6th power. And I think I've estimated pretty good there. Okay, so that's all I have for lesson 7.1 practice. If you had trouble with 7.2, make sure to check that video as well.